Right now, we're stood in the lower reaches of the Gallatin River system. This is a predominantly alluvial-driven system, with many driving and resisting forces, such as snowmelt and friction. If you consider the wetted perimeter, what you'll find is that the channel velocity is greatest near the center of the river. This is because at the channel boundaries is where drag is present. Drag can be understood as just the friction between water and the channel sides and channel bed. Also occurs at the channel boundary is the process of erosion and deposition. This interplay between channel velocity, deposition, and erosion is ultimately what causes sinuosity in a channel system. As the river comes down around this bend, as you can see, the center of the river will essentially impact with the far side of the channel boundary, eroding away at the boundary. Despite this soil being strong through vegetation and compaction, it is slowly being eroded away. This area is what we call cut bank. And you might ask yourself, well, where is the sediment going? Well, it's being deposited where I'm stood right here at the point bar. Point bar and the cut bank are both the depositional and erosional zones of a meandering river system. This is the ultimate system of sinuosity. If you break it down into the energy systems present in this environment, you can view it as boundary and critical shear stresses. Boundary stress is the amount of stress exerted on a bed due to the weight of water. So you might ask yourself, oh, is any amount of stress exerted on a bed able to transport? No. That is where critical shear stress comes into play. Critical shear stress is the threshold at which a particle of sediment is needed to be eroded and transported downstream. A better word for this is entrainment. Critical stress takes into account particle diameter and the bed uniformity. With both of these processes, there's a lot of confounding variables going on, such as cross-channel variances, gradients, velocity, many more things. But those, in summary, are the process of sinuosity and critical boundary stresses.